Hello everyone. So today is gonna be our day 20 of the DSA service Albedo. The question that we're gonna solve today is for sum. So when we solved this question yesterday, right, the two sum problem, I have put the link for three sum problem as well in the description as well. So make sure you check that out first. So for solving this four sum problem, right, you need to have the intuition for three sum first, and it will probably work on the same thing as two sum. Then it will be a better solution for a three sum. And then if you know how to solve three sum, we can probably jump on the four sum problem, right? So this is how the question says that given an array of n integers, return an array of all unique quadruplets num a, b, c, and d, such that this is the condition that a is less than b, less than c, less than d, and a, b, c, and d are distinct. This should, all the four things should be equal to target, and you may return the answer in any order, right? So let's just, I was just solving it before. So let's just try this out first, right? So this is the input and this is the target. Let me copy it and paste it here, right? Mm, okay, let's take this. Great. So the brute force, right? How will you how will you basically target this question is that the brute force should be you should absolutely run for loop for four times, right? So one I will be starting from here, then j here, then probably k here and l here. I know my k is not here, but okay, right? So 1 0 -1 0, and what is the target of it? You target is 0. Remember, you have to return all the answers, right? You have to return all the answers. So here, if you see the output, it contains all the possible answers. Great. So let's just see. So 1 plus 0 plus -1 plus 0. This is equal to 0, right? This is equal to 0. And what is the target? It is 0. So let's have an answer here which says that, hey, I will have 1, 0, -1, and again 0. Great. So you already have it. Now let's move on to here. Let's say our for my L moves here then, right? So what is it? 1 0 -1 0, sorry, -1, and then it becomes -2. What does this become? This becomes -2, right? And this is not equal to it. So our L moves forward. Again, this will not be equal to 0. This will be equal to, I guess, 2, and 2 is not equal to 0. Again, you will remove this. So now you have removed it, and your K increases. Your K increases. Now K comes here and L comes here, right? So again, let's write it. Let's write it out. Cool. So I is 1 plus J is 0, K is plus again 0, and this L is -2. So what it is nothing but -1. Again, -1 is not equal to it, so L comes here. What is it? Again, it will be 1 plus 0 plus 0, that is 1 only, plus 2, that is 3. So again, 3 is not equal to 0. We'll remove our K and L, sorry, remove our L, and L moves forward, but again, you don't have anything. So your K comes now here and L comes here. So 1 plus 0 minus 2 plus 2, right? This is what you have now, for your K, and it is equal to 0. What you will do? You will add 1, 0, -2, and then 2, right? Again, L moves forward. You don't have any L. So, so again, K moves forward. Now, K moves forward. You don't have anywhere to put your L. So basically, sorry, you don't have anywhere to put your L. So this, what did this become? This becomes that, hey, J, you move forward now. It's time for you to move forward. And this becomes my J, and this becomes my K, and this becomes my L, and so on, right? And what will be the answer? This will be the answer. Let's try to copy it. Let's try to paste it here, right? So this one, although this is sorted, but again, you can return in any order, right? You can return in any order. So we'll have a bunch of loops, right? So for I, which will start from 0 and go till n minus what? Now, this is something that you need to figure out, right? So, if my I can come here, my j could go here, k could go here, l could go here, but these are all out of bounds, right? I have to think of something that, hey, so that the last element, l should here, my k should be here, my j should be here, and my I should be here, right? These are my last four elements. So, okay, this is n minus 1, n minus 2, n minus 3, and n minus 4. So basically, this will run till n minus 4. Perfect. My j loop will start from I plus 1, goes till n minus 3. My k loop starts from j plus 1, goes till n minus 2. And again, the last loop will start from, hey, I'll say that L is equal to k plus 1, goes till n minus 1, and we'll calculate the sum. If it is equal to target, then return, basically push it. You will have an answer array here, which will save all your answers, and then at the end you will return your answer. Great. Simple time complexity, you will know that hey, this is nothing but O of n to the power 4, right? Four loops, so n to the power 4. Though again, I know people will argue that hey, we are not running L loop till we are not starting it from 0, we are not starting this from 0, this also not from 0, then why n? But again, you have to consider the worst possibility, right? You have to consider the worst possibility. So this is the time complexity and space complexity, although you are using this answer array, but again, this is for returning the answer, right? As you can see, the return type is an answer of an answer, an array of an array. So you can say that, hey, you are not using any extra space to solve the problem or solve the algorithm, but again, you are taking, so you can mention in front of the interviewer that, yeah, yes, we are using an extra space, but that is for returning answer only, and that is also given in the question that, hey, you have to return. So, okay, this is not an extra time space. Let's come on to a better, right? Okay. Again, if I just paste, okay, this is not what I wanted. This is not what I wanted. Um, Let me try to copy this and paste it somewhere here. Great. Okay. Now, if you remember from two sum, what we did was we used a hash thing, right? We use something called hashing there. Now, what is hashing? Basically, you will see that hey, sorry, if I already have an element which is equal to my if you remember the term that we used yesterday, it was something called as oh god, why am I forgetting it? Complement, yeah. What is complement? I told you that hey, if x plus y is equal to target maybe, and you already know x, you already know target. What is your y become? Y becomes target minus x, correct? And this y is a complement of x for target. This is what we learned yesterday in two sums. This is the same thing that we are going to follow when we are, going to solve this question. Okay. Okay. Let's try to, what we'll do now is we'll probably um, sort this array. Okay. Now, why are we sorting this array? You already know that you just need to return the elements and not the indexes. Had you been given that hey, you need to return the indexes and not the element, you would probably sort the array because hey, you need the indexes after all. And if you sort the array, you will probably turn on to you will lose on to the indexes of it, the original indexes. So let's try to sort the, oh sorry, this should be -2. This should be 0. Then again a 0. Oh, sorry. No, we already have -1 as well, right? So it should be -1, then 0, then 0, then 1, and then 2, right? I hope I'm not forgetting any element. Great. Let's put an I pointer here, a J pointer here, and a K pointer here. Cool. Let's have some hash thing. We can take anything. We can take a set. We can take anything, right? We can take anything. Okay. So what is I? I is -2. So -2 plus -1 plus 0, right? Is plus something. I can call it as probably x, right? I can already call it x. So will be equal to something. Should be equal to what? It should be equal to the target, right? It should be definitely equal to the target. It should be equal to target. Now what it is? It is -3 plus x. What is it? Is it equal to what? It is equal to 0. Now my x, the complement of these three is nothing but 3. So I need a 3 here, right? I need a 3 here. So do we have anything? No, we don't. We don't, right? We don't. We don't. So what we can do is we can put this element here, right? We can put this element here. Okay. So I can put the in my set. Now what I'll do, I'll move forward. I'll say that, hey, are you equal to, I think I'm missing something out here. Give me 1 second. Sorry. Yeah. So, where were we? We were here, right? So what I'll do is I'll find that, hey, if 3 was here or not, is 3 present in my, probably, in my set or not, right? Because since 3 is not present, great. I will move my k forward again, right? Now, what does my k look like now? Basically, what does my sum look like now? Then we'll calculate the complement, and then we can probably see if it is present in our sum or in our set or not. Again, what is it? It is nothing but -2 -1 plus 0, that is here k, and again that is 0 plus x. Is it present? Is it equal to 0? No, it is not, because again x will, what will the complement be? It will equal to again 3. Uh, is 3 present? No. What I'll do is I'll again push it in here. I know, I know. See, you can obviously, what you can do is, if it is already, now if it is, see, this will not be included in our set. Why? Because set holds only unique value. So see, this 0 will be present here already, so you don't need to push it again, right? Because it holds only unique value. So okay, we move forward. We come here. Great. Now I'll say that, hey, um, probably I, what is I? It is -2. What is -1? Then what is k? +1 plus x is equal to 0, right? X comes out to be nothing but 2, right? Is 2 present here? You will say, no, it is not. So I will push my 1 in it. That is the k element. The k element. Great. Okay. Is 2 present here? No, it is not. I move my k forward. Okay, here is my k. Now what is -2? Again, I'll be here. -2 -1 plus 1. Sorry, plus 2 plus 2. Since k is at 2, right? Plus x is equals to target. Now, what is my target? It will be equal to minus x will be equal to 1, right? Basically, this is my complement. Now I'll check that, hey, is my fourth element, that is 1, present already? You will say, yes, it is present in your set. What you will do is, hey, my answer should look like something like array of whatever it is. So ij, that is -2, -1. What is my k? This element, that is k, that is 2, and that is 1, right? I can put it in. Great. Now my k loop has ended. J comes here, or I can use this. J comes here, k starts from here again. Then again, array of I what is it, array of j what it is, array of k what it is. Then I'll have to find this set reset. Okay, so for people who are thinking, we'll write our code in such a manner that we will reset it. We will reset it. So probably it will be, this will be initialized after I and j loop, right? For people. So, okay. I hope you got the understanding, and let's try to write the code now. I'll again start from 0. Where does it go till? It goes till what did we discuss? We discussed n minus 4, right? It, it goes till n minus 4. Great. But now we will not make it go till n minus 4, right? Because we already know that, hey, I need to only find it here. So I will make it go till n minus 3. N minus 3. Uh, should it go till n minus 4 or should it go till n minus 3? Okay. We'll think about. We'll think about. So if it goes till n minus 4, then j goes from I plus 1 and goes till n minus 3, right? I will run, but here, this is where I will initialize my set. Maybe, I can say that, hey, temp set is equal to new set. This is equal to new set, right? And on the top of it, basically, when we start at it, I can initialize maybe a set here as well. Now, why am I initializing a set here as well? Because I need to return the answers, right? And my answer can be repetitive, maybe, I'm not sure. So that is why I will initialize a set here, right? With new set, great. So this temp set, and again, you will run a loop which starts from j plus 1, goes till n minus 2, or maybe n minus 1. Yeah, now I think I understand it. It goes till n minus 1, this goes till n minus 2, and this goes till n minus 3. I know my handwriting is bad, and the drawing I've made is the worst. Okay, let's try to write it again. Hmm. Okay, this goes till n minus 3, this goes till n minus 2, this goes till n minus 1, right? And then we'll calculate that if my all these sums basically, uh, you know, probably not here, not here. If not here, I will say that, hey, my fourth element, my fourth element is nothing but target minus, I can use this, sorry, target minus array of I plus array of j plus array of k, right? This is what it becomes. And now I will check. Now I will check that if my set has fourth, then you can probably, what you can do is you can say, sorry, not set, temp set. Then you can say that, hey, set dot maybe push, or whatever the syntax is, push the temp set, or not even temp set. You can say that array of I, array of j, array of k, and array of and fourth element, right? Else, push element, push my fourth element, that is fourth, in what? In what? In temp set. Correct? I hope you understand this. So what I'm doing is, what I'm trying to do is, I have created a set which will be an answer at the end. I'll run a loop I, I'll run a loop j, then I will initialize a temp set. which will hold these values, right? Which will hold these values for every new element that comes in the k loop, right? In the k loop. Then I will add the sum and find the complement of the fourth element. If it is present, then hey, temp set just push it inside you, right? What you can do is set. What you can do is you can push all the elements plus the fourth element. If my temp set already contains it, else do this. Great. What is the time complexity? Again, you are running three loops, and this is my time complexity, but my space complexity also increases. Now, why does it increase? Why does it increase? It increases due to the fact that you are using a temporary set as well, right? Interview cell will say that, hey, I don't need this thing. I don't need this thing. I maybe time complexity I can still work with, but I don't need your time. Right? Here comes your optimal or plus. And also for people who are thinking that why did I even sort it out? We don't need. We don't need. No, we don't need to sort basically. We don't need to sort. I now that I think of it, we don't even need to sort it. But here, when we are at optimal approach, we will be using a two-pointer approach, right? A two-pointer. Now I think we'll be using. Now I think we probably need sorting. If we sort this out, it becomes minus 2, becomes minus 1, becomes 0, then 1, and then 2, right? So O of n log n at the start only. Great. I will put my I counter here, J pointer here, right? Okay. Now I will use something which is called a two-pointer approach. If you remember in the two sum as well, we did use the same thing, right? We did. What I'll do is I will put my k here and my l here, right? And my I plus j. What is I plus j? It is nothing but minus 3. I need to find something. I have k element, I have l element. I need to make it equal to target. I need to make it equal to 0 right now because target is 0. Great. So what is my k? K is 0. That is 0 here. And L is nothing but 2. What does this become? Minus 3 plus 2, that is minus 1, is equal to target. Is it not? It is not. Is it greater than target or is it lesser than target? You will say, obviously, it is greater than. I will move my k pointer here. Now I will notice that hey, my k pointer is already equal to my previous element. So I will what I'll do is I will avoid the duplicates. I will say that hey, k pointer, you come here because that was equal to k minus 1 already. Now comes k. What does this become? Minus 3 plus 1 plus 2. Oh hey, this becomes equal to 0, right? This becomes equal to 0. My answer. Why I click on this? So my answer holds all the values of I, J, K, and L. Right? Great. Now J moves to this. Again, K starts from here, L starts from here. Okay, no problem. We'll again find it out. Right? This maybe it will have an answer or not sure. But when you bring your J, let's just say you find some answer here and you already push it. Then your J comes here. But again, you will notice that hey, it was equal to j minus 1. I will skip this and bring my j here. Bring my j here. But do you do you think that j should come here? So if my j comes here, my k comes here, and my l will go out of bounds. Obviously, it will start from n minus 1 basically. So we will start our I loop, which will start from 0 and will again go till n minus 4. My J loop will start from maybe, mm, okay, before that, I need to write something here. I will say if my array of I is equal to array of I minus 1, then I will say that, hey, continue, right? Because I need to keep the element. Then I will write that, hey, for let j is equals to I plus 1, simply j, you just go till n minus 3 and you will say j plus plus. Again, you will check if array of j is equal to array of j minus 1. I don't need you to go into it, right? Continue. Then I will say that, hey, let k is equals to j plus 1 and l is equal to n minus 1. I will say that, hey, while my k is less than l, if you remember, this is what we did in yesterday's problem as well. So if now I will have a sum here, basically here only, right? Let sum is equals to array of I plus array of j plus array of k plus array of l, right? So if my sum is equal to target, then so I will push all these I, j, k, l, right? I will push all these things. But now I will see. Now I need to check first that, hey, while my array of what? I will say that, hey, array of k is equal to array of, first of all, I will check while k is less than l, and array of k is equal to array of k minus 1. I will say k plus plus. What we doing on the stage. So, right? So this is what we did. While my k is less than l, and or maybe I can say that array of l also is equal to array of l plus 1, then l minus minus. This is what I am doing to avoid the duplicate. Then I will say that, hey, k plus plus l minus minus, right? Because we need, obviously, we need all the answers. We are not returning anything. If you remember, we are not returning anything. We are just pushing it inside. So if I use a different one, we are just pushing it. So that means we still need to find all the other elements if they are present here. We need to find all. That is why I'm doing this. L, L. Now, this is the if block. L, if my sum is lesser than my target, then what? K plus plus. L, you already know, then L minus minus. Right? Right? This is what we did. And then at the end of the day, you will return your answer. Let's try to code it up. And obviously, before coding up, let's try to see the time complexity. O of n, again O of n, and one O of n for, basically the two pointer. So, and almost of O n cube. Plus, if you remember, we did sorting as well. So, O of n log n, right? And space complexity, we are not using an extra space, but we are using an answer variable, but that is given in the question. So we are not using any extra space to solve the problem. We are only using it to return the answer. So let's try to code it. Let answer is equal to an empty array and n is equal to nums dot length. Great. Sort the array, right? Let's sort the array. So I'll say that, hey, nums dot sort, I will get two parameters A and B, I will say A minus B. This will ascending order, right? Great. I will run a loop. Let I is equals to 0. I goes till less than n minus 4 or maybe n minus 3. I plus plus for let j is equal to I plus 1. I will say that you should go till n minus 2 lesser than, we should go till n minus 3 basically, and j plus plus. Great. Now let k is equal to j plus 1 and L is equal to n minus 1. That is for sure. We need to have a two-pointer approach. While my k is less than L, I will run a while loop here. Great. So let sum is equal to not array, sorry, nums I plus nums of j plus nums of k plus nums of L. So if my sum is equal to target, what I'll do? I'll say that hey, answer dot push all these things. I will just simply put an array outside this, remove the plus sign. Remove this, remove this, and this, right? And hey, k plus plus, minus minus, L if my, what is it? My k is, sorry, my sum, if it is lesser than target, then you already know k plus plus, L, L minus minus, okay? Let's try to return the answer and you will notice that we will get TLE for it. Okay, we are getting a wrong answer because of this thing. So output should be only one, but it we're getting it multiple times. Okay, yeah, that is also one case I thought that it would surpass it, but okay. For that, okay, what you can do is you can either take a set of it, but this will give you a TLE. Now, why will it give you a TLE? Because we are not skipping the duplicate. So let's say that hey, if array of I and not array nums is equal to nums of I plus 1. Also, you need to check that, hey, if I is greater than 0, because obviously if I'm not checking this, because then it will always say continue. Sorry, it will not even consider the first element as well. But that is something that I need to do first of all, right? Here also, if j is greater than I plus 1 and array of j is equal to array of, not array, nums. Nums, right? Of j minus 1. Then again, continue, right? Here also we need to implement that same thing that, hey, while my k is less than L and an array of, not array, nums of k is equals to nums of k minus 1 triple equals to, right? We'll say that, hey, just simply k plus plus and here L minus minus L plus 1 here L. Now let's try to run this again and see if it gives the is the right answer or not. Probably it should. It is getting accepted. Let's try to submit it. Okay, great, great. Uh, Expected this, but we got this. And why is it so? Then what if we sort it out? Okay, let's try to add this in our test case that hey, what you have to do is, and target is 0, right? Uh, so this is my while loop. What I'll do is after J loop, I'll just say that maybe console.log answer, right? Or maybe not, maybe not. Let's try to do it in our favorite editor called Python Tutor, right? Where we can at least visualize it. I don't need this. I'll say that hey, console.log, what is the for sum, and it takes an array. And what is the array given? This is the array given. And what is the target? Target is nothing but 0. Let's try to visually execute it, right? Okay. So it's sorting. This is sorted array. Great. Now let's see. I is 0, right? And if I is, this will not run. Again, J is I plus 1, not equal to, okay, this will not run. This line comes now. K is nothing but 2 and L is nothing but 6. Great. So if sum is equal to this, now what does my sum become? Sum becomes minus 2. Minus 2, minus 1, minus 1 is 1. Is it so? Okay. This is minus, sorry, this is our 6. So these three elements and this, correct. So this becomes minus 2. Okay. This is not equal. So it is greater than, then L becomes, this becomes, my K comes to 3, right? K comes to 3. Great. Answer dot push. What is my sum? Sum becomes 0. Okay, this has been pushed. While what is my K here? What is my K here? 3. So it is equal to, oh, again, it is pushing the same thing, but that is not required. Okay. Mhm. What am I missing here? At the end, I am getting all these values only. Let's see. Let's see what are we doing here. Yeah, so basically I found the mistake, right? What we were doing is we were checking it with k minus 1 and l plus 1, right? Now, if we are checking it with that particular index and we were checking the behind element, right? We need to skip the further element as well. We need to skip the further element as well. And then we are already doing this k plus plus and l minus minus here, right? Had I not been doing that k minus 1 here and l plus 1 here, right? Then I could skip this and then it would give me the same answer. Now let's try to submit. Then give me accepted and it will probably get accepted as well. Great, accepted. Beats 846. Okay, that's not correct. That's not a very good example. Sorry, a good time. But again, it this runtime depends on many things on Leetcode, right? So you never have to get discouraged by seeing this. Hey, my time, the runtime is very high. Doesn't matter. We have already solved it, right? And if you see here, Okay. We don't have any follow-up question, but again, the follow-up question that I could have, asked here is that, hey, probably if you can solve it in lesser than n minus n cube, n to the power 4, it would be much better. And we are already doing it in n cube only without any extra space. So again, yeah, this question is solved. I hope you understood. You don't have to understand exactly how, the looping works, but you need to understand the two-pointer approach, right? This is something that is an optimization. The us skipping the what do you call it? The duplicates. Us skipping the duplicates is just an optimization. You don't need to worry about all these things. What you need to really worry about is running two loops, because you need to keep two things constant, and then you have to run loops between the remaining part from constant till n. You have to run a two-pointer approach, and that is something that is important. So uh, we can have keep two elements as constant and run a loop, run a two-pointer approach for third and fourth element to find the target. The target. Great. Let's try to save this. Let's remove it and let's mark it as done. Though the question is tiring, but you need to understand that, hey, this is a medium level question, and the only thing required is two-pointer approach. That is something that you need to really worry about, and you can use a pen and paper to, you know, see how things are going to work on, right? Thank you so much for joining in. I'll see you tomorrow with the longest consecutive sequence. Probably it requires TP. I'm not really sure. Um, okay, we'll see tomorrow, right? How this goes. Thank you so much for running in. I'll see you tomorrow with this question. And till then, just practice two sum and three sum. Very important. Four sum, not okay, is asked in FANG, but again, if you know how to solve three sum and two sum, you will be easily able to solve four sum only. Thank you so much. Bye bye.